Okay, so today we're going to take a look at some more domain and range here. We're going to start off with a warm-up on a radical function. This is a square root function. If you look at the domain of this function, remember domain is your x values here. So the first x value starts right here, and that number is actually 3. And then this function rolls out to the right side. I don't care about the up and down movement. I care about that it's going to the right or to the left when we talk about domain. So my domain here, if we're using, we could do this a couple ways. We could say x is greater than or equal to 3. Or if you like the intervals, you would say 3 with a bracket, comma, infinity. But infinity gets a parenthesis because we don't touch infinity. So if you don't touch the number, you use a parenthesis. The range on this guy starts right here on the x-axis, so that's a y value of 0, and then the function goes up, 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 and so it continues to go up. So we would say that the range, we could say y is greater than or equal to 0, or we could say with the intervals 0, comma, infinity. You don't have to do both of them, just pick one, pick which one you like. All right. Let me see, down below that it says use the graph to find the following values. I want to know what f of 4 is. Well, what is that asking me to do? It's saying, you know, normally when I say find f of 4, what you do is you take 4, you plug it into the function, and you tell me what the output is. So really what they're saying is when x is equal to 4, tell me what the y value is that goes with that. So if I go back over here to my graph for just a minute here, I'm going to erase some of this. If I go to where x is equal to 4 and I look at the graph right there, the y value there is equal to 1, so I know that f of 4 is equal to 1. Likewise, I can do that backwards. If it says that f of x is equal to 2, really what they're telling me is that y is equal to 2. Tell me what the x value is. So now I have to go to my graph and I need to find, I go to where y is 2 and I go over to my graph and it looks to me like y is 2 right here. So I've got this point that sits right there, okay? And the x value that goes with that is 7. So when it says f of x equals 2, they're saying, what's the x value when y is 2? Well, x is equal to 7, okay? Going to number 2, it says given h of x equals x squared minus 5, find h of negative 2. Again, referring back to what we just looked at, this means when x is equal to negative 2, tell me what y is. All right, so we're going to plug in negative 2 for x. We're going to square that and subtract 5. That's going to be 4, take away 5, so that'll be negative 1. Find h of x minus 1. Well, what does that mean? There's an x and a minus 1 here. What am I supposed to do? Well, just like when we substituted negative 2 back here in the first one, what they're saying is substitute x minus 1 in place of x. In other words, take out the x in the function and put in an x minus 1. So here we go. H of x minus 1 would equal, now my x is being squared, so I'm going to take out, first thing I'm going to do is take out the x, and I'm going to put in an x minus 1. Then I'm going to make sure that I square that whole thing, and then I'm going to subtract 5. All right? Now, we could leave it there or we could keep going. It just depends on what the question is asking for. So I'm gonna simplify it. I'm gonna keep going. So in order for me to keep going, I need to square this. So that's x minus 1 times x minus 1. Still have the minus 5 at the end. So we'll multiply these two guys together. X times x is x squared. X times negative 1 is negative x. Negative 1 times x is another negative x. And negative 1 times negative 1 is positive 1. And then I've got the minus 5. Combining like terms, I have x squared minus 2x minus 4 as my final answer. So if it just simply said to substitute it, I would put x minus 1 in and stop right here at the beginning. But we're going to assume that we're going to simplify unless it says otherwise. All right, whoops. All right, so again, today we're talking about domain again, but we're talking about domain of certain functions. So we're going to start off with a square root function. And square root functions have restrictions, okay? Square root functions, you cannot have negative numbers inside of a square root because then they're non-real. So what are the restrictions here? X cannot be negative. X cannot be negative. All right. Or you could also say the result in the radical cannot be negative. Okay. Or the result. Oops. I got to learn how to spell here. Let me go back here. The result in the radical cannot be negative. All right. So in this case, I just know that x has to be, in this case, x has to be greater than or equal to 0. Now, why is that important to know? Because when I look at the next one, okay, so when I look at the square root of x plus 6, x can actually be negative here. I could put in a -1, a -2, a -3. I could put in a whole bunch of stuff here. But if I know that what's in the radical cannot be negative, what that tells me is that what's in the radical, the x plus 6 that's inside the radical, that itself has to be greater than or equal to 0. If I can make that greater than or equal to 0, then I'm okay. So if we subtract 6 off of both sides, I know that x has to be greater than or equal to -6 in order for this statement to make sense, in order for this equation to make sense. All right, if I plug in a -7, I get -7 plus 6. That's the square root of -1. Now we're talking about a whole different thing here. So my domain would actually be x greater than or equal to -6. If we were going to do interval notation, we would say -6 with a bracket all the way up to infinity. Done. That was easy, wasn't it? Take a look at the next one. All right. Find the domain. Now, this time I've got numbers inside the radical and numbers outside the radical. These numbers outside the radical, they don't affect the domain at all. The only thing that affects the domain is what's inside the radical right here. So I don't care about the +7, I just need to keep that radical greater than or equal to 0. So I know that x minus 5 has to be greater than or equal to 0. If I add 5 to both sides, plus 5 on both sides, I get x greater than or equal to 5. So that 7 doesn't affect what's going on inside the radical. The 7 just affects after you plug in for x. All right? So this would be my domain right here. X is greater than or equal to 5, and I could stop right there. Or if I really like intervals, I could say that the domain is 5, infinity. You'll notice I don't even care about the 7 here. All right? So I would encourage you to shut off the video and try one on your own here. All right, so my focus again is right here. I don't care about the +11. I just know that -2x plus 3 has to be greater than or equal to 0. Okay, well, Mr. Cornelius, how does -2x stay positive? Well, let's solve it and see what happens. Let's do exactly what we did on the other ones. Let's subtract 3. So that's -2x is greater than or equal to -3. We're going to divide out the -2. And so we actually end up with x. And on the right side, we end up with +3/2. But we have something else that we need to keep in mind. When we divide an inequality by a negative, that sign flips over. So x has to be less than or equal to 3/2 in order for this radical to be a real number. So my domain is x less than or equal to 3/2. I could also say if I'm less than or equal to 3/2, that means I'm going from negative infinity all the way up to 3/2. So if I'm using intervals, I would have to write it like this: negative infinity, comma, 3/2, where I get to touch 3/2, but I don't get to touch negative infinity. All right? So how do we find the domain of a radical function? Just like we've been doing. The domain of a radical function is all of the x values. All right? It's all of the x values that, in my quotes here, that work. Okay? They're the x values that work. How do we do that? Just like we did in these three examples. We set the expression inside the radical. Set the expression inside the radical greater than or equal to 0 and solve it. Okay? Greater than or equal to 0 and solve it. All right, let's keep going here. Whoops, too far again. Let's back up here. All right, so now we're going to take a look at some rational functions here. Okay, so rational functions have asymptotes. The ones you've seen probably at horizontal and vertical, maybe some slants. We'll talk about those later. So I know that this function does not touch this vertical line or this horizontal line. So when I look at the domain of this, I think we saw one of these in the previous lesson. This thing, if you notice the arrow on the left, it goes out to the left forever. The arrow on the right, on the graph on the black part, shows that the graph goes out to the right forever. So we could say that the domain is x in the set of reals. Basically, x can be anything, but because of that vertical asymptote there, x cannot touch 0. The same thing with the y values. The black arrow goes up, the black arrow goes down. So we could say that this is y in the set of reals, but you can see that the y's don't touch the horizontal asymptote. Y is not equal to 0. The graph on the right looks almost the same as the one on the left, except it's just been shifted over 3 spots. So my domain, again, is x in the set of reals, but this time I don't get to touch positive 3, it looks like. My range, however, is exactly the same as the one on the left. Y in the set of reals, and in this case, y is not touching 0. Okay? So when we talk about rational functions, again, rational functions have certain things that happen sometimes. And so what are the restrictions on a rational function? Well, this particular rational function, basically any rational function, I'll start with the generic, okay? We never ever want to see 0 in the denominator, okay? So when we're talking about rational functions, we're talking about fractional equations, something that has a variable in the denominator. So the denominator of a fraction cannot equal 0. So if I look at this particular function, the only number that I cannot plug into there is 0. So x cannot equal 0 in this function. All right? So how do we find the domain of any rational function? We're going to find all of the numbers that make the denominator equal 0. So we'll find the ones that basically don't work, and we'll exclude these from the domain. Okay? So if I look at this first function, it's easy to see, I hope, g of x equals 3 over x plus 10. If I said, okay, what number could you not plug in to the denominator. Most of you could probably tell me negative 10 is not going to work here. That's great. You're right. Negative 10 doesn't work. But I'm going to start off by doing these and showing you how you can do this when they get a little more difficult. All I care about is the denominator. The numerator can be 0. It's no big deal. Well, this numerator will never be 0 because it's always 3. But I know that this denominator here, this piece, x plus 10, if I set this equal to 0 and I subtract 10 on both sides, I get x equals negative 10. That's the number I'm not allowed to use. Cannot use. Can't use. So my domain here would be x in the set of reals, x not equal to negative 10. That's the no-no. That's the one we don't want. Now, why did I write all that out when it was that simple? Because if I ask you letter B, what number could you not plug in? Most of you could tell me that 2 doesn't work, and you would be correct. But I'm going to take my x squared minus 4, x squared minus 4. I'm going to set it equal to 0. I'm going to solve it. Plus 4, plus 4. I'm going to get x squared equal to 4. I'm going to square root both sides, and when I square root both sides, take the square root of x squared and the square root of 4. When we square root both sides, we need a positive and a negative result here. So x is equal to plus and minus 2. So your answer of 2 would have been correct, but in order to do the domain here, we actually need to eliminate both of those values. So we could say that x is in the set of reals, but x cannot equal plus and minus 2. All right? So I would encourage you again at this point, turn off the video, try these last 4 on your own and see what you come up with. All right, so here we go. Find the domain of each function. Now, this first one's a radical, so we're going back to radicals here. So all I care about is this guy in here. I don't care about the 2 on the outside. That doesn't affect what's happening inside the radical. All I know is that 3x minus 4 has to be greater than or equal to 0. So we add 4 to both sides, plus 4, plus 4. We get 3x is greater than or equal to 4. Divide out the 3 on both sides, and we have x greater than or equal to 4/3. Guess what? There's your domain. You don't even need to do anything else. Domain's done. Letter B, I'm going to take the denominator. I don't care if x minus 3 turns out to be 0, because 0 up top's okay. 0 down below is a no-no. So 2x plus 1 equal to 0. I'm going to subtract 1 on both sides. I get 2x equals negative 1. Divide out the 2, and I get x equals negative 1/2. That is not my domain. That's the number that I can't use. This is a no-no. Can't use this number in my fraction for g of x. So my domain here, my domain is everything else. So we say everything else, x in the set of reals. However, x cannot be equal to negative 1/2. All right? Next one. Give the domain for each. Okay? Now, you look at this one and you're like, well, there's no square root and there's no fraction. So how do I do this? What do we do here? Well, I'm going to start off just by doing a quick sketch of this thing. This is basically y equals 2x plus 1. If I were to ask you to graph y equals 2x plus 1, I hope you could do that for me. Got a y-intercept at 1, slope of 2 over 1, 2 over 1. So really, this is just a straight line that goes like that. What's the domain of that thing? The domain here is all real numbers. X is in the set of reals. A straight line has a domain of all real numbers. Or you could simply say negative infinity, comma, positive infinity using the intervals. So a straight line is never going to have without some other restriction set upon it, it's always going to have a domain of real numbers. Kind of like letter B here. Letter B, how do I do this? Well, let's graph this and see what it is. Hopefully you recognize, what does x squared plus 4 look like? Hopefully you set a parabola. All right, now if I were to actually graph this, if I were to just plot some points, I could easily find out that the vertex is at 4, and the graph just goes up like this on the right, and like this on the left. What's the domain of that? It's x in the set of reals. So that's it. I mean, there's certain things that you want to be able to recognize, and those are 2 of them right there. And that ends lesson 1-3A.